Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss differential equations. In this chapter, we are going to discuss the concepts of exercise 9.4. In the previous class, we have discussed general and particular solutions of a differential equation. I hope you have understood the concepts of exercise 9.2. I hope you have learnt well the sums in the exercise 9.2. Okay, my children, as a part of revised syllabus in the mathematics, the exercise 9.3 is deleted. That is the concept formation of differential equation whose general solution is given. The formation of differential equation whose general solution is given. This concept was deleted. It means the exercise 9.3 was deleted. Okay, my children. That is why I have started exercise 9.4. 9.3 exercise was deleted in the revised syllabus. Okay, my children. Understood? Right. Now, come to the concepts of exercise 9.4. Are you ready to listen the class? Right. In this exercise, we discuss methods of solving first order, first degree differential equations. Okay, my children, how to solve first order, first degree differential equations. In this section, we shall discuss three methods of solving first order, first degree differential equations. How many methods are there? Three methods. We are going to discuss three methods of solving first order, first degree differential equations. Okay, my children. The first kind of differential equations are differential equations with variables separable. Okay, my children. Second one, homogeneous differential equations. And third one, linear differential equations. Here we discuss how to solve differential equations with variables separable. And in this section, in this case, we discuss how to solve homogeneous differential equations. And in this case, we discuss how to solve a linear differential equation. Okay, my children, understood these three methods, right? Especially in the exercise 9.4, especially in the exercise 9.4, we focus on solving the differential equations with variables separable. Okay, my children, in the later exercises we discuss these three methods. Okay, my children, right. Now come to the second point, my dear children, differential equations with variables separable. Here we are going to discuss how to solve the differential equation by variables separable. Okay, my dear children. A first order, first degree differential equation is of the form dy by dx is equal to f of x comma y. Okay, my children, that let us consider this is a given differential equation. Let us assume that this is equation 1. Okay, my children, please listen these steps carefully, my children, because this method will be useful in solving homogeneous differential equations also. Okay, my children, this knowledge will be carried forwarded in solving the differential homogeneous differential equations also. Okay, my children, right. If f of x comma y can be expressed as a product g of x into h of y, where g of x is a function of x and h of y is a function of y. Then the differential equation 1 is said to be of variable separable type. Understood this point, my children? Suppose this f of x comma y can be written as a product of two functions, namely g of x into h of y, where g of x denote a function in x and h of y denote a function in y. In this case, we can say that this differential equation is said to be of variable separable type. Understood this point, my children? Right. The differential equation 1 then has the form dy by dx is equal to h of y into g of x. Let us consider this is equation 2. Because this function f of x comma y can be expressed as g of x into h of y. In the place of f of x comma y, we have written g of x into h of y or h of y into g of x. This is a second step. Recommendation. Understood this one? Right. If h of y is not equal to 0, separating the variables, equation 2 can be written as 1 by y dy is equal to g of x into dx. Here we have transposed g of y to LHS and here dx is transposed to RHS. Understood this point, my children? Then this equation changes to this form 1 by h of y dy is equal to g of x dx. Understood this step, my children? In this stage, we have separated the variables. All the y functions in LHS into dy is equal to the entire function in the x. The entire function in x into dx. In this stage, we say that the variables were separated. Okay, my children, understood this step? Right. Let us consider this is equation 3. Okay, my children. Integrating both sides of equation 3, we get, if we are integrating on both sides, then we get integral 1 by h of y dy is equal to integral g of x dx. Understood this point, my children? We have integrated this equation on both sides, then we get to this step. Let us consider this is equation 4. Thus, equation 4 provides the solutions of given differential equation in the form of h of y is equal to g of x plus c. You know, plus c denotes arbitrary constant of integration. Yes or no, my children? Right. Here, h of y and g of x are anti-derivatives of 1 by h of y and g of x respectively. Understood this point, my children? So, in this method, we have to separate the variables like this. The entire function in y into dy is equal to the entire function in x into dx. We have to change the given differential equation into this form. After that, we have to integrate on both sides. Understood these steps, my dear children? Right. The concepts of exercise 9.4 were completed. Okay, my children. Now let us start the sums in the exercise 9.4. See page number 395 in the textbook. Okay, my children. Right. Come to the first question. Question number 1. Find the general solution of the differential equation dy by dx is equal to 1 minus cos x by 1 plus cos x. Okay, my children, understood this question? We have to find the general solution of this differential equation. Right. Come to the solution part. Let us write the given differential equation. That is dy by dx is equal to 1 minus cos x by 1 plus cos x. Okay, my children? Right. This implies dy by dx is equal to, if you observe this one, this is completely a function in x. There is no function in y. There is completely function in x. So here we separate the variables by separating the variables. By separating the variables, we get here dy is equal to, we are transposing dx to RHS, that is equal to 1 minus cos x by 1 plus cos x dx. Here we separated the variables. In RHS, the function, the entire function is in x. There is no function in y. So just we are transposing dx to RHS. Then we get this step. We wrote dy is equal to 1 minus cos x by 1 plus cos x into dx. Understood this step? But is learned. We have separated the variables. After separating the variables, what is the next step? We have to integrate on both sides. Integrating on both sides, we get integral dy is equal to integral 1 minus cos x by 1 plus cos x dx. Okay, my children, understood this step? We have integrated this equation on both sides. Then we got this step. Okay, my children, right? Integral dy, del dy is equal to y. Whereas here integral 1 minus cos x by 1 plus cos x. Let us modify this function so that we can integrate this function easily. Okay, my children. So by using the trigonometric identities, by using the knowledge of applying trigonometric identities, integration by using trigonometric identities. This 1 minus cos x can be written as 2 sine square x by 2. 1 plus cos x can be written as 2 cos square x by 2 dx. Okay, my children, because 1 minus cos x is equal to 2 sine square x by 2. 1 plus cos x is equal to 2 cos square x by 2. By using these two trigonometric identities, we wrote the numerator and denominator. Understood this step, my children? Right. Here 2 gets cancelled. This implies here integral dx is equal to x. In LHS we used that formula. Integral dx is equal to x. Integral dy is equal to y. Okay, my children? Right. So y is equal to integral sine square x by 2 by cos square x by 2. How can you write this function? Tan square x by 2. Yes or no, my children? Tan square x by 2 dx. This implies in y is equal to, we don't know directly integral tan square x by 2, tan square x dx. We don't know that formula. So we convert into secant square x by 2 minus 1. Tan square x by 2 can be written as secant square x by 2 minus 1 dx. Because tan square a is equal to secant square a minus 1. Okay, my children, understood this step? Right. This implies y is equal to integral tan square x by 2 integral secant square x by 2 dx minus integral dx. There are two terms, so we can integrate these two terms separately. So we integrated like this. Understood this step, my children? Right. This implies y is equal to integral, it is in the form of integral secant square of ax plus b. Then what is the formula? Tan of ax plus b by a. So tan of x by 2 by 1 by 2. Here a means coefficient of x. Okay, my children, minus integral x. Integral dx means x, because integral secant square of ax plus b dx is equal to 1 by a tan of ax plus b, and integral dx is equal to x. So by using these two integral formulae, we wrote this step. Okay, my children, understood this step? Right. This can be written as y is equal to 1 by 2 becomes numerator, then it becomes 2. 2 tan of x by 2 minus x. Okay, my children. So integration part is over. This is the last step. Simplification part is also over. So at last step we add constant of integration. Okay, my children. This is the required general solution of the given differential equation. Understood, my children? Right. Now come to the question number 2. Second question. Find the general solution of the differential equation dy by dx is equal to square root of 4 minus y square, where minus 2 less than y less than 2. Okay, my children, this is the given differential equation. We have to find general solution of this differential equation. Understood this question, my children? Right. See here, let us write the given differential equation. Dy by dx is equal to square root of 4 minus y square. Okay, my children, if you observe this equation, here in RHS, the entire function is in y only. There is no function in x. In the previous question, the entire function is in x, whereas in this question, the entire function is in y. Okay, my children, there is no function in x. So let us separate the variables by separating the variables. We get so we had to transpose this function in y to LHS. Okay, my children. So 1 by square root of 4 minus y square into dy is equal to, we had to transpose dx to that side, RHS. Understood this step, my children? Right. Please remember this point, my children. We always transpose dx to that side, RHS. Okay, my children, in this separating the variables method, we always transpose dx to that side. Okay, my children, then we get this step. After separating the variables, what is the next step? We have to integrate. Integrating on both sides. Then what you will get? Integral 1 by root of 4 minus y square dy is equal to integral dx. Yes or no, my children? Understood this step? In this equation, we are integrating on both sides. Then we got this step. Okay, my children? Right. Now, come to the LHS. Now, let us convert this function into the form of 1 by root of a square minus x square form. Let us convert this function into integral 1 by root of a square minus x square dx form. Okay, my children, but variable is y. It is different case, but variable is y. So we converted this function, we converted this integrand in the form of integral 1 by root of a square minus x square dx. Okay, my children, in RHS integral dx is there. What is the value of integral dx? X. Integral dx is equal to x. Understood this step, my children? Right. So this is a integral of well-known form. We know the function in this form, the integral of this form. Then what is the integral of 1 by root of a square minus x square? Yes, sine inverse x by a. So sine inverse What is x here? Y. By what is a here? 2. Okay, my children, is equal to x. Okay, my children, understood? Because integral 1 by root of a square minus x square. What is the formula? Integral 1 by root of a square minus x square. Sin inverse of x by a. 1 by root of a square minus x square dx is equal to sin inverse of x by a. So by using this integral formula, we wrote this LHS. Okay, my children, understood this point? Right. So integration part is over. Okay, my children. Now we have to add constant of integration. So sin inverse of y by 2 is equal to x plus c. Okay, my children. So you can stop this solution by this step. Otherwise, we can use the knowledge of inverse trigonometric function. Sin inverse of y. Sin inverse of y by 2 is equal to x plus c. This can be transposed to RHS. Then y by 2 is equal to sin of x plus c. Okay, my children. You can stop this answer by this step, or you can expand by using the previous knowledge of inverse trigonometric function, because sin inverse x is equal to y implies sin y is equal to x. By using this inverse trigonometric functions knowledge, we wrote this step. So this implies y is equal to 2 sin of x plus c. So you can say this is also general solution of the given differential equation, or you can say this is also general solution of the differential equation. Understood, my dear children? Right. Now come to the third question. Question number 3. Find the general solution of the differential equation dy by dx plus y is equal to 1. Y is not equal to 1. Okay, my children, understood this question? We have to find the general solution of this differential equation. Right. Come to the solution part. Given dy by dx plus y is equal to 1. Okay, my children. Right. Now we have to convert dy by dx is equal to, first we have to convert this function into the form of dy by dx is equal to some function RHS. Okay, my children, this implies after that step only we separate the variables without writing dy by dx is equal to some function. Without doing that part, we can't use separating the variables method. Okay, my children, that is why we write dy by dx is equal to 1 minus y. We are transposing plus y. We are moving plus y to RHS. Then it becomes minus y. Understood this step, my children? Right. Right. This implies here the differential equation is a transport is changed like this. Dy by dx is equal to some function in y. Yes or no, my children? Right. So this can be written as dy by dx is equal to, let us take minus common. So minus of y minus 1. Okay, my children, understood this step? I have taken minus 1 from these two terms. Then we get minus of y minus 1. Then the dy by dx is equal to some function in y. Okay, my children, understood this step? Now by separating the variables, by separating the variables, we get dy by y minus 1 is equal to minus dx. Previously I told you we have to transpose dx to RHS and we write the y function to LHS. Understood this statement, children? By separating the variables. we wrote the entire function in y into dy is equal to the function in x into dx. Okay, my children. After this stage, after separating the variables, what is the next step? Integrating on both sides. Okay, my children. Remember these steps, my children. Integrating on both sides. This implies integral dy by y minus 1 is equal to minus integral dx. Okay, my children, understood this step. I am integrating this equation on both sides. Understood this step, my children? Right. Now it is in the form of integral 1 by ax plus b. What is the formula? 1 by a into log of ax plus b. So log of y minus 1. Okay, my children, minus integral dx x. Okay, my children, because integral 1 by ax plus b dx is equal to 1 by a log mod ax plus b, and integral dx is equal to x. So by using these two integral formulae, we wrote these two parts. Understood this step, my children? Right. So integration part is over. Simplification part is also over. There is no simplification part. Okay, my children. So log of y minus 1 is equal to minus x plus c. So this is a constant of integration, because this is the last step. At last step we add constant of integration. Understood this step, my children? Right. We can stop by this step. Otherwise we can use the previous knowledge. This is log of a base c. This can be written as y minus 1 is equal to e power minus x plus c. Okay, my children, this can be written like this also, because a power x is equal to b implies log b base a is equal to x. By using the concept, by using the knowledge of logarithm and exponential functions, we converted this logarithmic function into the exponential function. Understood this statement? Otherwise you can stop this answer by this step. Okay, my children? Right. This implies y minus 1 is equal to, this can be written as e power minus x into e power c, because a power m plus n can be written as a power m into a power n. By using the laws of exponents, I wrote this term as e power minus x into e power c. Okay, my children, understood? Right. Now come to the question number 4. Fourth question. Find the general solution of the differential equation secant square x tan y dx plus secant square y tan x dy is equal to 0. Okay, my children, understood this question? We have to find the general solution of this differential equation. Okay, my children? Right. Come to the solution part. Let us write the given differential equation secant square x tan y dx plus secant square y tan x dx is equal to 0. Okay, my children? But this differential equation not, it is not in the form of dy by dx is equal to f of x comma y. Okay, my children. So first of all we have to convert this differential equation into that form. Dy by dx is equal to, in LHS there should be only dy by dx. Okay, my children. So for that, let us move this term to that side, or they move this term to that side. Secant square y tan x dy is equal to, just I am transposing, I am moving this term to RHS. See, minus secant square x tan y dx. Understood this statement, children? Just I transpose the term to RHS, then it becomes this. Then we get this step, secant square y tan x dy is equal to minus secant square x tan y dx. Okay, my children? Right. Now let us separate the variables. All the functions in y in LHS into dy is equal to the entire function in x into dx. In this way, let us separate the variables by separating by separating the variables. By separating the variables, we get, what should we do here? In LHS, the entire function should be in y. So secant square y is there. Secant square y. In RHS, there is tan y. So transpose that to tan y to LHS. Then it becomes by tan y. Okay, my children, understood this point? Into dy. There is no function in y. Then the function in y is moved to LHS. Then it becomes 1 by tan y. Then we got secant square y by tan y is equal to dy. Similarly here tan x is there in the LHS. We transpose that tan x to RHS. So minus the secant square x by tan x into dx. Understood this statement, children? In this step, we have separated the variables so that the entire function in y into dy is equal to the entire function in x into dx. Okay, my children? So this equation is comfortable to us to integrate. Okay, my children? Now integrating, after separating the variables like this, integrating on both sides. Integrating on both sides. Then we get integral secant square y by tan y dy is equal to minus integral secant square x by tan x dx. Okay, my children? Right. Now it is in the form of, understood this step, my children? Right. Now it is in the form of integral f dash x by f of x. If you consider f of y as f of x, then its derivative is tan y, derivative is secant square y. As our number children, d by dx of tan x, secant square x. So it is in the form of integral f dash x by f of x. Then what is the formula? Log mod f of x. So log mod tan y is equal to minus, here also we use the same integral formula, log mod tan x. Tan x. Okay, my children, because integral f dash of x by f of x dx is equal to log mod f of x. Okay, my children, understood this step? Right. Now let us transpose this term to LHS. Then it becomes log mod tan y plus log mod tan x. Okay, my children, is equal to 0. Okay, my children, understood this step? Right. Or you can write plus is equal to c, some constant. We are adding some constant here. Okay, my children, understood this step? Right. This can be written as log mod tan x into tan y is equal to c, because log a plus log b is equal to log of ab. Yes or no, my children? By using this logarithmic property, I wrote this LHS part is equal to c. Okay, my children, understood this step? Then this implies tan x into tan y is equal to e power c, because log a base c is equal to x implies e power x is equal to a. By using this logarithmic property, I wrote this step. Understood this step, my dear children? Right. Which is the required, general solution, or you can write as a c also. E power c, it is also a constant. Okay, my dear children. So tan x into tan y is equal to c, where e power c is equal to c, some constant. It is also some constant. So we can write any other constant is equal to c, which is the required general solution. Which is the required general solution of the given differential equation. Understood this point, my dear children? Right. Here I am not explaining the question number 5, question number 6, question number 7, question number 8, question number 9 and question number 10, because all these questions are of the same type, finding the general solutions of the differential equations. Okay, my children. So I am leaving these questions to you. Please try these questions yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Now the second part of this exercise. Second part. What is this second part? Find the particular solution. Find the particular solution of the differential equation x cube plus x square plus x plus 1 into dy by dx is equal to 2x square plus x, y is equal to 1 when x is equal to 0. Okay, my dear children. Here also, what is the question here? We have to find particular solution. In the previous questions, we have found general solutions of the differential equations. Now we have to find particular solutions of the differential equation. Particular solution of the given differential equation when y is equal to 1 and when x is equal to 0. This is just a little bit extension to the previous method. Means first of all, here also we have to find general solution of this differential equation. First of all, we have to find the general solution of this given differential equation. In that general solution of the given differential equation, we have to substitute y is equal to 1 and x is equal to 0. Then we get the value of c. In the previous problems, we did not get the constant of integration, the value of constant of integration. Yes or no, my children? In this case here, we get the value of c. That is only the difference between general solution of the differential equation and a particular solution of the differential equation. Okay, my children, understood the difference? Right. Come to the solution part. Given x cube plus x square plus x plus 1 into dy by dx is equal to 2x square plus x. This is the given differential equation. So let us convert into the form of dy by dx is equal to f of x comma y. Here this entire function is in x. So we have to transpose to RHS and dx also. Previously I told you we have to transpose dx also to RHS. Then what will you get? By separating the variables. By separating the variables, we get dy is equal to 2x square plus x by x cube plus x square plus x plus 1 into dx. Understood this step, my children? I have transposed x cube plus x square plus x plus 1 by dx to RHS. Then it becomes dx by x cube plus x square plus x plus 1. Yes or no, my children? Right. Understood this step, my children? Right. This implies dy is equal to Now after separating the variables, what should we do? Integrating on both sides. Yes or no, my children? So integrating on both sides. Integrating on both sides. Then we get integral dy is equal to integral 2x square plus x by x cube plus x square plus x plus 1 dx. Okay, my children, understood this step? Right. This implies integral dy is equal to, what is the value of integral dy? Y only. In LHS we get y. Integral dy equal to y. Now come to RHS. It is a rational function. Yes or no, my children? Rational function. F of x by g of x. Okay, my children. Moreover, it is a numerator. The degree of the numerator is 2. Here the degree of the denominator is 3. So it is a proper rational function. Okay, my children. Right. So 2x square plus x by, let us take x square from these two terms. So what will you get? X plus 1 plus 1 into x plus 1 dx. From these two terms I have taken 1 as common factor. Okay, my children. So here to integrate this function we use the knowledge of integrating by partial fractions method. Okay, my children, because this is a rational function. Numerator is also a polynomial in x, denominator is also a polynomial in x. So it is a rational function. So in this case we use the knowledge of integrating by partial fractions method. Okay, my children, because integral dx is equal to x. For LHS we use this integral formula. Okay, my children, this implies y is equal to integral 2x square plus x by, what we get here by taking common factor x plus 1, x square plus 1 dx. If you observe here, it is a linear factor, it is a irreducible quadratic expression. Do you remember that point, my children, how to write the partial fraction for this one? Yes. Let us consider this is the equation 1. Let us take this part. Let 2x square plus x by x plus 1 into x square plus 1 is equal to, here we are writing the partial fractions for this proper rational function. What is the partial fraction? Here it is a non-repeated linear factor. So corresponding to this non-repeated linear factor we write a partial fraction like this, a by x plus 1. Understood this point, my children? Do you remember this partial fraction? Right. Now come to the second factor. It is a irreducible quadratic expression. For corresponding to a irreducible quadratic expression, we write a partial fraction like this, bx plus c by x square plus 1. Okay, my children, let us consider this is equation 2. Understood this step, my children? Here we are integrating this function. So for integrating this rational function, we are using the knowledge of integration by partial fractions method. For that we wrote partial fractions. So in this partial fractions we have to find the values of a, b and c. Okay, my children. So let us consider this is equation 2. Okay, my children. Right. Do you remember the steps, my children, to find the values of a, b and c? Yes, first of all we have to take the linear factor in the rough part. So x plus 1 is equal to 0. This implies x is equal to minus 1. From this equation we have to find the value of x. This is rough part, rough work. So we have got value of x. We have to substitute. Now let us simplify here. 2x square plus x by x plus 1 into x square plus 1 is equal to, here by taking LCM, x plus 1 into x square plus 1. Okay, my children. Then what will get? A into x square plus 1 plus bx plus c into x plus 1. Understood this numerator part, my children? Right, here we get cancel. So then what will get? 2x square plus x is equal to a into x square plus 1 plus bx plus c into x plus 1. Okay, my children, let us consider this is equation 3. So in this equation, we substitute this value x is equal to minus 1. Then we get one value, either a or b or c. Okay, my children. So put x is equal to minus 1 in the equation 3. Then what we get? 2 into minus 1 whole square plus minus 1 is equal to a into minus 1 whole square plus 1 plus b into minus 1 plus c into minus 1 plus 1. Understood this statement, children? In this equation, I substituted x is equal to minus 1, then we got this step. Okay, my children, then what will you get here? 2 minus 1. I am writing directly. 2 minus 1, what will you get? 1. Here, a into 2. So, 2a. Here we get 0. So, I am not writing 0 here. Okay, my children. So, what will you get? A is equal to 1 by 2. This implies a is equal to 1 by 2. We got the value of a. After getting the value of a, there is no non-repeated linear factor. Okay, my children. After that, we have to equate the highest power of x on both sides. What is the highest power of x in LHS? 2. What is the highest power of x in RHS? 2. So, by equating or by comparing coefficients of x square on both sides, we get, do you remember these steps, my children? Here what will get? X square quotient a plus here bx into x. Here also x square term is there, so coefficient of x square is b. Understood this? A plus b, my children, is equal to, here what is x square quotient? 2. Okay, my children. So a is equal to 1 by 2 plus b is equal to 2. I am substituting the value of a in this equation. Okay, my children. This implies b is equal to 2 minus 1 by 2. This implies b is equal to, what will you get? 2 2 is 4. 4 minus 1, 3 by 2. So value of b is equal to 3 by 2. Okay, my children. Understood this one? After comparing the coefficient of x square, we have to compare coefficients of x on both sides. By comparing the coefficients of x on both sides, we get, do you remember all these steps, my children? Integration by partial fractions method, we are using that previous knowledge only here also. Okay, my children, this implies this side a into 1, this is a constant, there is no x term, so a. From this expression, what will you get here? Constant is a plus c. Yes or no, my children? Plus c is equal to 0. Here constant term is not, so sorry, x coefficient, we have to compare x coefficient. What is x coefficient here? We don't get here. Bx into 1, so we get b as x coefficient, plus here x coefficient is cx, so x coefficient is c. Understood this point, my children? Here x coefficient is 1. From LHS as well as in RHS, we have to take coefficients of x and we compare them. Understood this step, my children? Right. This implies, what is b here? 3 by 2 plus c is equal to 1. This implies c is equal to 1 minus 3 by 2. Then what will you get to? Minus 1 by 2. Therefore, C is equal to minus 1 by 2. We got all the values of A, B and C. Now let us substitute all these three values in this equation 2. Okay, my children, understood this one? Right. So by substituting A is equal to 1 by 2, B is equal to 3 by 2 and C is equal to minus 1 by 2, in the equation 2 we get 2x square plus x by x plus 1 into x square plus 1 is equal to 1 by 2 by x plus 1 in plus 3 by 2x minus 1 by 2 by x square plus 1. Okay, my children, understood this step? Right. This implies 2x square plus x by x plus 1 into x square plus 1, integrating on both sides. Okay, my children, integrating on both sides. Integrating on both sides. Integrating on both sides. We get integral 2x square plus x by x plus 1 into x square plus 1 dx is equal to 1 by 2 integral 1 by x plus 1 dx. Here I am separating the integrals directly. Okay, my children. Plus 3 by 2 integral x by x square plus 1 dx minus 1 by 2 integral 1 by x square plus 1 dx. I wrote these two terms as three terms. Okay, my children. Because here 1 by 2 integral 1 by x plus 1 plus this fraction can be split into two fractions, 3 by 2x. So 3 by 2 into integral x by x squared plus 1 minus 1 by 2 by x squared plus 1. Understood this step, my children? I wrote this step directly. Okay, my children? Right. This is equal to 1 by 2. What is the integral? 1 by x plus 1 log mod x plus 1. Okay, my children? Plus 3 by 2 integral. Here multiply and divide by 2. So 1 by 2 into integral 2x by x square plus 1 dx minus 1 by 2 integral t is in the form of 1 by x square plus 1 tan inverse x. Okay, my children? That is equal to, because integral 1 by ax plus b dx is equal to 1 by a log mod ax plus b. For this first term we used this formula, and integral 1 by x square plus a square dx is equal to 1 by a tan inverse x by a. We use this formula for the second. Okay, my children, understood this step? Right. That is equal to 1 by 2 log mod x plus 1 plus 3 by 4. It is in the form of f dash x by f of x. So log mod x square plus 1 minus 1 by 2 tan inverse x. Okay, my children, understood this step? So plus c. Okay, my children. So substitute this value in the equation 1 by substituting integral 2x square plus x by x cube plus x square plus x plus 1 dx is equal to 1 by 2 log mod x plus 1 plus 3 by 4 log mod x square plus 1 minus 1 by 2 tan inverse x plus c. In equation 1 we get, what we get? Y is equal to, yes or no, my children? Y is equal to 1 by 2 log mod x plus 1 plus 3 by 4 log mod x square plus 1 minus 1 by 2 tan inverse x plus c. This is the general solution. Yes or no, my children? This is the general solution of the given differential equation, which is the general solution of the given differential equation. Okay, my children? Understood this one? Right. After finding the general solution of this differential equation, we had to find the particular solution of the differential equation. What is given? Put y is equal to 0 and x is equal to 1 in the above equation. Then we get the value of c. In this general solution, we substitute y is equal to 0, y is equal to 1 and x is equal to 0. So what is given? Y is equal to 1 and x is equal to 0. We had to substitute y is equal to 1 and x is equal to 0. See the question, my dear children. They have given y value and x value. We had to substitute these two values in this general solution. Then we get value of c. Okay, my dear children. This implies 1 is equal to 1 by 2 log mod 0 plus 1 plus 3 by 4 log mod 0 square plus 1 minus 1 by 2 tan inverse 0 plus c. Okay, my children, this implies 1 is equal to c, because this value also 0, the value of this term also 0, the value of this term also 0. Finally, we get only c. This implies c is equal to 1. Therefore, particular solution of the given differential equation is, write the general solution of the differential equation plus the value of c. Okay, my children, y is equal to 1 by 2 log mod x plus 1 plus 3 by 4 log mod x square plus 1 minus 1 by 2 tan inverse x plus, in the place of c, we have to substitute the value of c. C is equal to 1, which is the required particular solution of the differential equation. Okay, my children, we try the question number 12, 13 and 14, my children, same as that of question number 11. After finding the general solution of the given differential equation, you have to substitute the given values of x and y in the general solution of the given differential equation. Then we get the value of c. Again, we have to substitute the value of c in the general solution. Then we get particular solution of the given differential equation. Okay, my children, understood? Right.